Hello and welcome back to this channel. Dear students, this session is quick revision part 3 of the subject microcontrollers. We will be revising unit number 5 and unit number 6. So first part is port structure. This is an important concept from the exam point of view. We may expect the question like this. Draw the diagram of port structure of PIC 18F and explain its operation using SFR, special function registers. You need to remember some basic points, like there is one command which is trace. If trace is 1, it indicates input. If it is 0, it indicates output. Then we are using two MOSFETs in this diagram, P MOSFET and N MOSFET. उससे related conditions पे आप लोगों को याद रखना है. P MOSFET का इनपुट अगर 0 है तो ऑन है, इनपुट 1 है तो ऑफ है. N MOSFET के लिए इनपुट 0 है तो ऑफ है, and if input is 1, it is on. ये जो इनपुट है, इनपुट फॉर P MOSFET इज डिनोटेड बाय E, इनपुट फॉर N MOSFET इज डिनोटेड बाय F. अब ऑन है कोई भी MOSFET मींस इट विल एक्ट एज अ शॉर्ट सर्किट, मींस देयर विल बी डायरेक्ट कनेक्शन. इफ इट इज ऑफ, इट इंडिकेट्स ओपन सर्किट, दैट मींस नो कनेक्शन. Let us discuss first condition. That means we want to write the data. There are two conditions. You can write 0 or you can write 1. Suppose I want to write 0. This is writing operation. So port must be acting as an output port. इस आउटपुट के लिए ट्रेस बिट का वैल्यू 0 होना चाहिए. अब दो फ्लिप फ्लॉप्स है यहाँ पे. One is acting as a data latch, another is acting as a trace latch. We want to write 0. So data latch should be 0 and trace latch must be 0 because 0 indicates output port. हम लोगों को write करना है तो आउटपुट करना है, मतलब इसका वैल्यू 0 होना चाहिए. So this Q of data latch will be 0. This Q of trace latch will be 0. अब Q and Q bar are complement of each other. Q 0 है तो Q bar 1 है. Q bar का ये कनेक्शन पॉइंट A को दिया है, so A is 1. Q of trace latch is also 0. इसका कनेक्शन B को दिया है, तो ये कंटेंट्स है 1 0. This is OR gate. If input is 1 0, output is 1 1 है, इसका मतलब this MOSFET. Look at the conditions. If it is 1, P MOSFET is off. यहाँ पे मैंने लिखा है. Look at the second gate, that is AND gate. ये A का कनेक्शन डायरेक्टली यहाँ पे A1 है तो C भी 1 है. D का कनेक्शन Q बार को है. हम लोगों ने डिस्कस किया Q फॉर ट्रेस इज 0, सो Q बार इज कॉम्प्लीमेंट, सो इट इज 1. तो ये बिट D 1 हो गया. तो C and D बोथ आर 1. इट मींस आउटपुट ऑफ AND गेट इज 1. यहाँ पे लिखा है मैंने. इफ आउटपुट ऑफ AND गेट इज 1, इट इज एक्टिंग एज इनपुट टू NMOS. NMOS का इनपुट अगर 1 है तो इट इज ऑन, तो यहाँ पे लिखा है मैंने NMOS इज ऑन. इसका मतलब ये ऑफ है तो इट इज आउट ऑफ क्वेश्चन. इट इज ओपन सर्किटेड. ये ऑन है मतलब शॉर्ट सर्किट. अब देखो ये ड्रेन टर्मिनल है, दिस इज गेट टर्मिनल, दिस इज सोर्स टर्मिनल. सोर्स टर्मिनल इज ग्राउंडेड एंड दिस MOSFET NMOS इज ऑन, मींस देयर विल बी डायरेक्ट शॉर्ट सर्किट. मतलब यहाँ पे ये ग्राउंड है मतलब 0 है तो यहाँ पे 0 आ जाएगा एंड दिस 0 विल बी अपीयरिंग एट द आउटपुट. दिस इज द वे यू कैन राइट 0 using this port. Now second condition, suppose we want to write 1. Again we have to write the values. That means trace bit should be at 0 because it is acting as an output port. This port will be acting as an output port. So trace will be 0, trace latch is 0 and data latch is 1 because we want to write 1. तो यहाँ पे मैंने 1 लिखा है, ये 1 आ गया, data latch का Q 1 आ गया है. अब Q and Q bar और कॉम्प्लीमेंट, ये 1 है तो ये Q bar 0 आ गया. यहाँ पे ट्रेस लैच के लिए ये Q 0 है क्योंकि यहाँ पे 0 है तो Q 0 है, तो ये B बिट 0 आ गया, मतलब A 0 B 0. दिस इज OR गेट. 0 0 का आउटपुट 0 होता है. दिस इज PMOS. फॉर PMOS, लुक एट दिस कंडीशंस. इफ 0 इज द अप्लाइंग एट द इनपुट, वी आर अप्लाइंग 0 एट द इनपुट, देन दिस इज ऑन. तो यहाँ पे मैंने लिखा है PMOS ऑन. यहाँ पे देख लो A एंड C आर सेम. A 0 है तो C भी 0 है. ये Q 0 है यहाँ पे ट्रेस लैच के लिए, क्योंकि ट्रेस मतलब आउटपुट एंड फॉर आउटपुट वी नीड टू अप्लाई 0, तो ये Q बार 1 हो जाएगा. तो ये बिट C एंड D, दैट मींस इनपुट्स टू द AND गेट आर 0 1, आउटपुट इज 0. AND गेट का इनपुट अगर 0 1 है तो आउटपुट 0 है. 0 इज अप्लाइड एट द इनपुट ऑफ NMOS. तो NMOS का कंडीशन देख लो, NMOS 0, इट इज ऑफ, तो यहाँ पे मैंने ऑफ लिखा है. वेरी सिंपल. NMOS इज ऑफ, दैट मींस दिस इज ओपन सर्किटेड, नो कनेक्शन विल बी देयर. दिस PMOS इज ऑन. ये ऑन है मतलब यहाँ पे शॉर्ट सर्किट हो जाएगा. यहाँ पे हम लोग VDD दे रहे हैं तो डायरेक्टली ये VDD यहाँ पे आ जाएगा. VDD मतलब लॉजिक 1, तो आउटपुट में लॉजिक 1 आ गया. दैट मीन्स वी आर ट्राइंग टू राइट 1 and at the output we are getting 1. Next is how to perform read operation. Suppose आउटपुट में 1 है और हमें वो 1 रीड करना है. It is reading operation, so port should act as an input port. For input port, trace bit must be 1. So it is 1 for input. So I have written trace latch is 1. Data latch, we don't want to write anything. So data latch is X, means don't care condition. So I have written here X. Since Q is X, Q bar is also X. Look at values of Q and Q bar. It is XX, that is don't care condition. This value is for trace latch. For trace latch we need to apply bit 1. So ये Q1 हो जाएगा. Q bar is complement, तो ये 0 हो जाएगा. ये 1 यहाँ पे अप्लाई होगा. तो input of this OR gate will be don't care and 1. If any one of the input is 1, other is don't care, then output of OR gate will be 1. ये 1 है, तो this PMOS, look at the conditions. PMOS for 1 acts as off, तो यहाँ पे मैंने off लिखा है. यहाँ पे देखो A और C सेम है. A don't care है, तो C is also don't care. D bit is connected to Q bar 0 है, तो D 0 आ गया. If any one bit, input bit of AND gate, this is AND gate, is 0, output is 0, तो ये F output of AND gate will be 0. 0 is acting as an input to NMOS. NMOS के लिए 0 है, तो NMOS ऑफ हो जाएगा, तो यहाँ पे मैंने ऑफ लिखा है. दोनों मॉसफेट ऑफ है, मींस दिस विल एक्ट एज ओपन सर्किट. तो ये सर्किट बिल्कुल नहीं आएगा बिकॉज इट इज ओपन सर्किटेड. यहाँ पे जो 1 लिखा है वी कैन रीड इट थ्रू दिस लैच. सो दिस इज how we can read value 1. Same way if you want to read 0 value, तो यहाँ पे 0 apply करेंगे. Similar conditions and these two MOSFETs will be off and we can read 0. This is about the port structure of PIC18F microcontroller. This is the diagram of LCD interfacing. From the exam point of view, you may expect the question like this. Draw interfacing of LCD with PIC18F microcontroller and also explain the pins RS, read write pin and enable pin. So this is the diagram of LCD interfacing. I have shown these data lines D0 to D7, they are connected to port D. You can make use of any port like port B, port C and so on. So RD0 to RD7, these are the port D pins, total 8 pins, and they are connected as data lines. This is 16 character 2 line LCD display model. Then these pins VCC, VE and VSS, these pins are connected to ground by using one potentiometer. Value of this potentiometer is 10 kilo ohm. This value is 10 kilo ohm. So by varying this wiper, by changing the position of this value of resistance, we can adjust the contrast of this LCD display. Then about these 3 pins, RS, read write pin and enable pin. Before that, there are 2 types of registers. One is command register, another is data register. As the name indicates, command register means whether you want to write something, that means you want to send the data to the LCD and that data will be displayed, or already data is displayed and you want to read the data. So these are the commands. These commands are handled by using command registers. That is function of command registers is for read and write especially. Then another type of registers are data registers, as the name indicates, which is responsible for the data. Then RS pin, about this pin. If RS is equals to 0, we will be using command register, and if RS is equals to 1, we will be using data register. Then read write pin. This is read oblique W bar, that is read write pin. When this pin is made 0, it indicates you want to perform writing operation. That means you want to display something using LCD display. When it is 1, it means you are performing reading operation. Then this pin is E, that is enable pin. Whatever command you are giving, that command should be latched for certain time. So it is used for latching. This E pin or EN, enable pin, is used for latching, and for latching the data, high to low transition is required. Now to make high to low transition, I have written this subroutine. First make E or enable EN, any notation will do, E or EN. First be E is equals to 1, then apply delay. then make E is equals to 0 and then return. Very simple. So this is used for latching the data. That means it is used to apply high to low transition. Then I have written certain commands which are required while performing the programming part. So 0x01 it is used for clear display, 0x04 it is used to shift cursor left, 0x06 used to shift cursor right, then 0x08 display off cursor off, that means both display and cursor will be switched off. Then 0x80 move cursor at the beginning of first line. See, suppose we are using 2-line LCD display. Generally we are supposed to make use of 16:2, that is 16 character 2-line display. In that case, to make a movement of cursor at the beginning of first line, command is 0x80. Same way, if you want to make a movement of cursor to the beginning of second line, corresponding command is 0x C0. Then 0x38 is used to initialize 2-line display, and 0x0f it is used for display and cursor both on and both are blinking. So this is about the interfacing of LCD display with the PIC18F microcontroller. So by making use of these commands, you can write the corresponding program. I have already explained the programming part in the detailed video. So just now I just brushed up the things related to this LCD interfacing. Next part is interfacing of LED. So this is the diagram which shows LED interfacing with PIC18F microcontroller. This remaining part is same like the earlier interfacing diagrams. We are connecting one oscillator, crystal oscillator between OSC1 and OSC2. This is master reset terminal, that is master clear terminal. Suppose the question is like this: draw an interfacing diagram and write a program for flashing of LED connected to port D. Port name can be different, it can be port B, it can be port C, whatever. So presently I am using port D, so pin numbers RD0 to RD7 are used. At the output of each pin, register is connected. This is current limiting register. In this case, this microcontroller will provide the current, so it is acting as a current source. So 330 ohm, every line contains 330 ohm resistance, which is current limiting resistance, and then LED is connected. This is the common ground connection. So this is the delay program. Suppose we want to provide a delay up to 50 milliseconds, then the delay program is void delay unsigned integer y time. We are considering one integer unsigned, which is y time. Then let us define unsigned integer I and unsigned character j. Use two loops. For I is equals to 0, I less than y time, I plus plus, j is equals to 0, j less than 165. From where we got this value? This is related to 250 millisecond delay. So it depends on the compiler. Let us say this value is 165 corresponding to 250 milliseconds delay, and j plus plus. This is the delay subroutine. Now main program, trace D is equals to 0 because we are using port D as an output port where we have connected LEDs. Then while 1 we want to continuously flash the LEDs. So while 1, port D 0x55. We have discussed in earlier video that flashing means alternate LEDs should be on and off. So it is 0x55 and another command is 0xAA. Then apply delay every time, delay to 50 milliseconds. So this is the simple program, and this is the interfacing of LED with microcontroller. Next part is PIC test board. This is an interfacing diagram related to PIC test board, in which we have shown the connection of LED, then relay and buzzer and corresponding switch. You can write the explanation like which we discussed in earlier videos, like about the crystal oscillator which is connected between OSC1 and OSC2, then about this master reset condition and so on. These names are optional. I mean, I have shown LEDs connected to pin RA0 through some resistor 320 ohm. Of course, this is current limiting resistor as we have discussed while studying interfacing of LEDs. Then this is the switch position. This is connected to RB port B, pin RB0. Then this is the relay connection. We are using one NPN transistor. Then it is connected to RC5, and buzzer again we are using transistor, NPN transistor for connection of a loudspeaker, and it is connected to pin RD4. These are few steps related to this designing of PIC test board. Initialized trace bit, we know that we'll have to make a corresponding port as output port or input port, in output or input port depending on the requirement. For example, here I have shown LED connected to port A, so port A must be acting as an output port because this is acting as a source current which is applicable for switching on the LED. Then check the switch position. Whenever the corresponding switch is closed, we'll have to generate the corresponding action like switching on LED and so on. Then when switch is closed, LED must be on, buzzer must be on, and relay should be energized. Then depending on the application, transfer the content to the corresponding ports. Here I have shown only one connection of LED. You can show the number of LEDs connected to different port pins. So this is the generalized diagram related to PIC test board. Next part is home protection system. Let us discuss one question. Draw home protector system using motion detectors and air sensor. Display the status on LED and LCD. In simplified language, what is asked in the question? You need to draw interfacing diagram which will work as home protection system. We'll be using PIR sensor, that is passive infrared sensor. The functioning of this sensor is that whenever any human passes across that sensor, then there will be temperature variations and that will be detected. So output of this PIR sensor is connected to pin RA0 of PIC 18F microcontroller. Then suppose our requirement is that it is asked in the question to display the status on LED and LCD. So I have shown the interfacing of LED displays. This is the buffer which is used for LED display, as well as I have shown this diagram shows interfacing of LCD. We have already separately discussed about this interfacing of LED and interfacing of LCD. Recall the things. These pins RS, read write pin and enable pin are connected to port D pins RD0, RD1 and RD2. Data lines D0 to D7, D0 to D6 are connected to port C of PIC microcontroller RC0 to RC6. This resistance is used to adjust the contrast of LCD display. Now suppose we will make the design such that we are using two switches S1 and S2, and our requirement is that whenever switch S1 is pressed, then the LED display will show the corresponding display, and when switch S2 is pressed, which is connected to pin RE1, then LCD display will be activated and status will be displayed on the LCD. So whenever there is some motion, then PIR sensor detects that motion and give the corresponding output to RA0. We have to adjust all these things while writing the coding, that when S1 is pressed, then LED will show the corresponding display, and when switch S2 is pressed, LCD will show the corresponding display. It is asked in the question, draw the interfacing diagram. So this is complete interfacing diagram. Apart from this, if it is asked, show or indicate the status by using buzzer or relay, then same way you can connect buzzer as well as relay. One more thing, not necessary that you need to use 7-segment display. You can use separate LEDs for the indication. So this is about the interfacing diagram of home protection system. Next is RS-232 and RS-485 protocols. RS-232 is asynchronous serial communication protocol, whereas RS-485 is EIS standard protocol. It makes use of, this RS-485 makes use of transmitter and receiver on a single twisted pair cable. Now, as far as this part is concerned, the comparison is most important. I have made a comparison between RS-232 protocol and RS-485 protocol. First part is, for RS-232, we need dual power supply, whereas for RS-485, single power supply of 5 volt is sufficient. Then this protocol, RS-232, is limited only for 2 devices. This is applicable for multi-drop interface, means many devices can be interfaced. You can extend number of devices up to 256. Then distance maximum can be extended up to 15 meters. This can be extended up to 1200 meters. Basically, RS-232 is full duplex communication system, whereas this is half duplex communication system. Maximum speed is 19.2 kbps for 50 feet distance. This is 10 mbps. Input voltage levels for RS-232 are plus minus 3 volt DC, and for this it is 0.2 volt DC. Then output current for RS-232 is 500 milliamperes. For RS-485 it is 250 milliamperes. RS-232 protocol makes use of single-ended cables, whereas RS-485 protocol uses balanced differential cable. Now listen, remaining part of unit number 6, I have written the points. I2C mode of MSSP structure. We are supposed to draw this diagram and explain. Then Bragg register, interfacing diagram of RTC with PIC 18F microcontroller, features of EEPROM, interfacing diagram of EEPROM, then UART or USART transmitter and receiver block diagrams and explanation, comparison of I2C and SPI, and features of I2C and SPI. ऑल दीज आर थ्योरेटिकल पॉइंट्स. ये सब थ्योरेटिकल पॉइंट्स है और मैंने जितना एग्जाम पॉइंट ऑफ व्यू से रिक्वायर्ड है उतना ही उस वीडियो में कवर किया है. सो आई एम रिक्वेस्टिंग यू टू वॉच ऑल दीज वीडियोज रिलेटेड टू दीज पॉइंट्स विच आई हैव ऑलरेडी क्रिएटेड. जैसे मैंने बताया इलैबोरेटिव नहीं है, सो अननेसेसरली आई डोंट वांट टू रिपीट द सेम थिंग्स, क्योंकि मैंने जैसे बताया उस वीडियो में जितना रिक्वायर्ड है उतना ही एक्सप्लेन किया है. सो प्लीज रेफर द वीडियोज रिलेटेड टू दिस which all are available in the playlist. So dear students, thanks a lot for watching this video and all the best for your exam.